Shall we start?
Yes, sir.
Okay, fine. Is it visible to everyone?
Yes, sir.
Okay, in earlier lecture, we started the piping drawing, and now we are discussing about the dimension of drawings. Some of the dimensioning of drawings in finished. Now we'll see the dimension of drawings. So in the dimension of drawings, we'll see the sufficient dimension to be given for positioning equipments and for erecting pipings. And now we will discuss the next points for dimensioning of lines. Horizontal nozzles on the pipe equipment shall be located from center to flange face in plan. Later we'll see the what is a plan. And for vertical nozzle, show the face of flange elevation. That is, we call the F of F. That is nothing but face of flange elevation. Now, as far as concerned for the wall and instruments and non-standard equipment, show the dimension from flange to flange face. So that of dimension we have to consider to in dimensions the sketching lines. So that kind of dimension see in the facing of the line. So here you have seen the reference lines, and another is here elevation. So that kind of dimension we have to consider in for walls, instruments, and non-standard equipment. Show the dimension from flange face to flange face. And flange walls are located with dimension to flange face. Non-flange walls are dimension to their centers or stems. For flange joints, show all small gap. See here, flange joints, we can see the small joints, small gap between the dimension lines to indicate the gaskets. Flange joints can also be shown without gasket but cover the same with a general note and include gasket thickness in the wall or equipment dimensions. For finished floor, we call the FF. The elevation shall be the high point of the floor. For foundation, the top of ground, we call the TOG elevation. So in this case, so mark the dimension outside the drawn view. Do not cut pictures, whatever we are drawn. So we need not to cut the pictures. So therefore, we have to consider their particular dimensions outside the drawn views. And then draw the dimension lines unbroken with fine lines, right? Dimension just above the horizontal lines. Here you can realize, write the dimension just above the horizontal lines. For vertical lines, write sideway. These are the rules writing the dimensions, and the dimension lines can be terminated with arrowheads or oblique dashes. So here we can see the arrowheads or oblique dashes. And if series of dimension, so what kind of series of dimension? We'll see through the sketch. So this is the series of dimension. So if a series of dimension is to be shown, the string them together show overall dimension of the string of dimensions. Avoid one of the breakup dimension to omit repetition and error during changes. And do not omit significant dimension other than the fitting makeup. For Field run piping give only those dimensions which are necessary to route piping clear of equipments and other abstractions. Locate only those items which are important to the process. Underlying out of the scale dimension or mark as NTS, and do not terminate dimension at screw or welded joints. Now this is all about the dimensioning in piping drawings in different industries. Now our third point slash concern, this dimension is the checking up piping drawings. So checking up piping drawings, see some key points. Checking shall be done only on the print or check plot of the drawing and by color pencil or pens. First, corrected areas and dimension are marked yellow colors. Area and dimension which are to be deleted are marked green. Area to be corrected and incorporated on the drawing are marked in red. With the help of this color coding, so we can finalize the drawing with the help of yellow colors, green colors, and red colors. These are the standards, but some industry follow their own standards. They can change the colors for correction, the area and dimensions. Mark yellow instead of yellow, they will consider different. Before that, they have to mention that kind of colors we are considered for the area and dimensions in piping drawings. And the new print after the correction is back check for incorporation. We have to mark the new print to the correction is a back check for incorporations. Point to be checked on the drawing. What kind of points we have to consider on the piping drawings through checkings. First, title of drawing. This is very important. Then orientation, north arrow against plot plan. Inclusion of graphic scales if drawing is to be reduced. Then we have to consider the graphic scales. Now next is the coordinates of equipments against the equipment layout and equipment numbers and their appearance on the piping drawings. Then correct identification on all lines in all views. Line specification changes, reference drawing numbers and files, correction of all dimensions, whether a representation is correctly made in line with the standard symbols or not. Location and identification of all instruments, requirement of upstream, downstream, straight lengths, and insulation requirements as per P&D's process and instrumentation diagrams. Piping arrangement against P&D requirements such as gravity flow, seals, etc. Possible interference and correctness of scale in case of general arrangement drawings. Next is whether all stress analysis requirements are met or not. We have to consider these points for checkings. Now next is adequacy of clearance from civil structure, electrical apparatus and instrument consoles. Next one is a floor and wall openings and accessibility of operation and maintenance space and provision of dropout and handling areas. Foundation drawings and vendor equipment requirements. Detail and section identification must be matched. Match line provision and accuracy. Presence of signatures and dates. So which concern person. So here signature and dates. Accuracy of BOM in isometrics. BOM's bill of material in isometric and number of issues and revisions. This is very essential to consider that kind of points while checking the drawings in piping engineering. These are the very important key lines whenever we have to consider. Now here we can see the isometric plan and elevation. So based on isometric, we can draw the plan and elevations in piping drawings. So as far as concerned, the isometric views here clearly shows the piping arrangement, but the plan view fails to show the bypass view, loop and wall and other supplementary elevation view is needed. So but plan sometimes plan view fails to show the bypass loop and wall and supplementary elevation. The view is needed. So to provide a full information using orthographic drawings and the number of drawings will be increased. For reading and understanding a piping isometric drawings, one should learn the piping isometric drawing symbols thoroughly. Some of the symbols we are already discussed in the earlier slides. Then how to read the isometric drawings. An isometric drawing is drawn with a single line. This single line symbolizes the center of the pipe and any dimension shown to it, it is always center to center of the system. And to read piping isometric drawing must know the piping isometric drawing dimensions are always from center to center of pipes. Pipe size is always written at any connecting point of isometrics. Coordinate and elevation of pipe is written at connecting points of piping isometric drawings. Material description for pipe is described in piping isometric drawing on top right corners. Rolling in isometric drawings are shown with hatches. In case of rolling up pipes, its conventional direction not remain same to north, south, east or west. So here seen the basic requirement for reading isometric drawings. So here through with the help of this plan and elevation and we can plot the isometric plans. So suppose here isometric view is given. Based on that, we have to draw the plan as well as elevation. If elevation and plan is given, then we have to draw the isometric view in orthographic projection with the help of grid papers. So that kind of paper we call the grid drawing papers. So with the help of this paper, we can draw the isometric as well as plan and view. So here we can see the tanks. Here three tanks in plan. See the bigger circular and then two small circulars and remaining. So here we are provided the walls. So different kind of walls are provided with different ends and yeah, mark that kind of walls in the plan and then elevation, then we'll draw the first smaller tank and then draw the bigger one. So both are on the coincides, therefore we have to show only one tank. So here we are terminated means it is uh, bigger than the actual, so we cannot show the exact dimension of a tank, so we can terminate in between. And then here in elevation, so we have shown the different walls with reducers, that is a different kind of reducers, face side upper or face side lower. So that kind of reducers, so mark in elevation based on the isometric view. So use grid drawing papers and draw the isometric as well as the plan and elevation. If you have any doubts, any question, how to draw the isometric view and elevation and plans. Yes. Yes. Any doubts? Any questions? Anushka, Sarthak, Bhagyasri, Shubhangi, Ayush, Adesh.
No, sir, no doubts.
Okay,
No, sir.
fine. Anyone? Okay. Yes, Ayush Patel. Are you there? Okay. Adesh.
No, sir, no doubt.
Okay, fine. Now we'll proceed. Uh, Next parameter, uh, that is plot plan. So with the help of this plot plan, so we'll see the basic definition of plot plan. So the section of project site is a major corporate decision considering the various factors that make the plant technologically and economically viable. Industrial policy of the government is a major factor to be considered. Availability of the various supporting facilities such as power, water, effluent disposals, manpower, etc. have also been taken into consideration along with the size and nature of the industry. Once the site selection is done, the next activity is to develop the plot plan. So then what is a plot plan? Plot plan is the master plan locating each unit or facility within the plot boundary for a process industry such as refineries, agrochemicals, petrochemicals, organic chemical, inorganic chemicals, fertilizers, pharmaceuticals, metallurgicals, and power generations. Development of plot plan is a much involved job. While locating the various units, facilities within the plot, consideration shall be given for the operation, maintenance, safety aspects related to the plant and that of the neighbors, fire hazardous, location of power and water supply, expansion facilities, man material movements in a balanced manner. Before the activity of development of the plot plan starts, there is a lot of data related to all disciplines of engineering to be collected and analyzed and or made use of. Data to be collected before starting can be from various engineering sections or departments. So in basic data, first one is a civil engineering. In civil engineering, we'll see the plane table survey map. Then next one is a contour survey maps, and next one is a soil surveys. So in plane table survey map, this document shows the extent of plot with overall areas identifying all the existing constraints such as transmission lines, structures, fonts, place of worship, if any, etc. The survey covers 20 to 30 meters beyond the extent of the specified plot to show the nearby roads, drains, and broad feature of the neighboring plots. This will also show the geographical north direction, the location of power and water connection are also shown. So this is very important. We have to consider the plane table survey in plot plan layouts. Now next is here the the data sheets. We have to consider the different kind of plot plans are used. With the help of plot plan, we can consider the different kind of arrangements in engineering plot plans. So here we can consider the plane table survey maps, contour survey maps, and soil survey maps. So here in soil survey map, it is conducted to establish the bearing capacity of the soil, which will be required for the civil design. The nature of the soil is also tested to determine the expansive nature, corrosion properties, that kind of properties we have to require. Now, next is electrical. The data related to electrical will be constitute the supply voltage levels, the voltage levels required within the plant, and faulty levels to establish the power distribution system, the location of supply point to decide the location of the receiving stations, and the requirement of the state electricity boards. These are the points we have to cover, say, in electrical engineering sections. The next parameter is non-plant facilities. What kind of non-plant facilities? In non-plant facilities, necessary data is required to be collected to arrive at the block size of the different utilities. Before the work is started on the development of plot plan, the user department should be consulted to arrive at the requirement, and the allocation also be proportionate to the available plot area and effective process area. So what kind of facilities required in non-plant facilities? First one is administrative block. Second one is a canteen. Third one is workshop. Next is R&D, QC quality and control laboratories, and pilot plants. Next one is a gatehouse or time house, security arrangements, vehicle parkings, medical centers, warehouse. In warehouse, which parameter we have to cover in warehouse? First one is a covered area, open area, solid warehouse, then liquid warehouse. The next non-facilities, that is steel or scrap yards, fire stations, weighbridge, and last point is a stop colony. So these are the non-planned facilities. This is required to collect it to arrive at the block size of the different non-planned facilities before the work is started on the development of the plot plans. The user department should be consulted to arrive at the requirement, and the location allocation should also be proportionate to the available plot area and effective process area. Now, next parameter is meteorological data. So, in meteorological data, that is to arrive at the location, to arrive at the location, to arrive at the location of the process area, utility areas, and type of enclosure required for the building, basic design parameters, the drainage details. This data means meteorological data, minimum, maximum, and normal temperature during the year. Now, next one is a rainfall and intensity and direction of the wind, and seismic zone, wet and dry bulb temperatures, flood levels. So these are the points we have to survey under the meteorological data. Now, next is a process data. A lot of data related with the working of the process plant is also required to develop a plot plans, size or capacity of the process unit to work out the area to accommodate the same. Knowledge on the type of plant, whether it is to be located indoor or outdoors, or the extent of enclosure required. Sequence of process flow to locate the process unit in the proper manners. Hazardous nature of the plant to keep proper inter-unit distance and work out the fire water storage problems. The overall operating philosophy of the plant is fully automatic, partially automatic, manual, or batch or continuations. The next one is raw material receipt and product dispatch philosophy. Then storage philosophy. The requirement above the ground and or underground storage. The nature of storage materials are required to decide on the block size, effluent plant capacity and discharge points in certain requirements. This type of hazard to decide fire hydrant systems and number of layers in industries. So, these are concerned about the process data. Now, next one is data on utilities. The data on utilities are required to gather to size and locate the various utilities, source and or supply points of raw water, quality of water available, water consumption for the process, and requirement of different types of utilities such as steam, air nitrogens, and water, that is soft waters, cooling waters, chilled waters, and marine solutions. Capacities and the grouping philosophy based on the nature of utilities. Now, next is statutory requirements based on the location, nature, and type of the plant. The requirement by the statutory authorities as well as spelled out knowledge and application of these are essential to develop the plot plan. These talk about the requirement of the green belt, floor area occupation, and floor space index, width of the road, free area to be maintained along the plot boundaries, height and tread of the steps, floor to floor distance, requirement of distance to be maintained between the units, requirement within the petroleum storage and gas storage, firefighting requirements, height of chimney. These requirements are laid down as per the norms set by State Industrial Development Corporation, we call SIDC. This is the first statutory body, and second is Central or State Environmental Pollution Control Boards, we call PCBS. Now, next is a factory inspectorate. Now, next is a state electricity boards, we called ACB or MACB. Or next one is the chief controller of explosives. So here we call CCOE, that is chief controller of explosives. The next one is the static and mobile pressure vessel rules, we call SMPV. The next is tariff advisor committee, that is we call the TAC. That kind of statutory bodies laid down some certain rules. Another is aviation laws. Chief Inspector of Industry, Oil Industry Safety Directorate. We call Food and Drug Administration, that is we call the FDA. The next one is Ministry of Environment and Forest. We called the MOEF. So that kind of authorities are concerned with the statutory requirements in a different industry. It may be refinery industries, organic, non-organic, agro industries, chemical industries. So that kind of industry is required for developing the plot plans. Now, next philosophy is the expansion philosophy. So, in expansion philosophy, within the unit and additional units should be considered while developing a plot plan. The expansion could be segregated as near future expansion and far future expansion, and both should reflect in the overall plot plans. Now, next is that is develop development plot plans based on the data collected. So whatever we are mentioned the data collected, that is basic data in basic data under the civil engineering. In civil engineering section, we'll see the plane table survey maps, contour soil map and soil survey maps. Electrical section, non-plant facilities, meteorological data, process data, data on utilities, and statutory requirements, and expansion philosophies. So now next parameter in the process industry is the development of plot plans based on the data collected as we discussed above all the sections. Then see the detail work out so that this can be used for the development of plot plans. First one is a block dimensions. In block dimension, process plans considering the expansion philosophies. Then utilities based on the grouping philosophy and expansion requirements. Electrical receiving station and substations. Now next one is uncovered storage space and solid warehouses. Now next one is non-explosive chemical storage or explosive chemical storage as per the classification, the chemical engineering section. Next one is the petroleum storage as per these classifications. Then fire water storage requirements, acid or alkali storage, steel and scrap yard, raw material storage and treatment facilities. Then next one is a contractor side. The next one is effluent treatment and incinerator the plants. Then a flare stacks. The next parameter under the development of plant is control room, administrative buildings, workshops, canteens, laboratories, pilot plant. Then tentative detail a pipe rack and sleepers. Then interdistance based on the type and nature of the process. Then safety distance for the storage based on the relevant statutory regulations. Then what kind of point we have to consider? Normally construction is permitted maximum on 50% of the plot area with total build-up area equal to the area of the plant. That is we call the floor space index FSI. Depending upon the regulation governing the area and type of industry. Then, area reserved for tree plantation shall be one third of the area occupied. Parking space, that is 10% of the plot area. Water storage capacity 24 hours minimum. Then we have to consider some points, basic points can be used to estimate the water requirements. Domestic water 100 liters per person per day. Then water requirement for boilers, steam rating into working factors. Then cooling towers 1.5% of the capacity as the drift and blow down losses. Then washings 10 to 15 liters per day per square foot of floor area of the plant. Then next parameter is gardening. 5 liters per day per square feet of garden areas. Then the next parameter is height of boiler chimney in meters. So here we have to consider the 4 into Q raised to half, where Q is the quantity of SO2 generated in kg per or that is sulfur. So based on that, we have to consider the height of boiler chimney in meters. Now next steps to be considered while developing plot plans. The study the contour map and establish the grade levels and terrace. Then establish north, south, or east, west on XY grids. The plan north in relation to geographical north. Establish the free area along the plot boundary as per the statutory norms. Work out the area requirements for the green belts, vehicle parkings as per the norms. The process blocks shall be located in the sequential order of process flow so that material handling, that is solid or liquid, is minimum. Blocks shall be arranged considering prevailing wind directions so that flammable gases do not get carried to source of ignition. Then storage tank shall be grouped according to process classifications. Then centralized control room shall be located in safe area close to process plant. Two adjacent process units shall be located based on annual shutdown philosophy so that hot work shall not affect the operations. In process unit shall be located on higher ground away from the unwanted traffics. Process units shall be serviced by peripheral roads for easy approach. Utility block shall be kept at safe area close to process plants. Electrical substation shall be placed at the load center to minimize cabins. Then receiving station shall be placed near the supply points. Then warehouses shall be located to close the material gate to avoid truck traffics within the process area. Now next one is flare, furnace, heaters, cooling towers shall be placed depending upon the wind directions. Provision of future expansion shall be considered. So here we are discuss about the steps to be considered while developing a plot plan. Some steps are remain. If you have any questions, any doubts, so you can ask your doubts or questions regarding the earlier piping drawing checkings and plot plans. Within plot plans, we have seen the different kind of data requirements for the refineries, refinery industries, or chemical, agrochemicals, petrochemicals, organic chemical industry, and fertilizers, pharmaceutical industries, metallurgicals, and power generations. And later we will discuss about the basic datas. The civil engineering's first one is a plain table survey map, contour survey map, soil survey, then different sections, electricals, non-plant facilities, meteorological data, process data, data on utilities, statutory requirements, and expansion philosophy. And then later we are discuss about the development of the plot plans and steps to be considered while developing plot plans. Few steps are remain for developing plot plans. If you have any questions, any doubts, you can ask your doubts or questions. Yes, anyone? Yes, Siddesh, Prajakta.
No doubt, sir.
No, sir, no doubt.
Okay. Sarthak, do you have any question? Okay. Okay, fine. Then we'll close this session here and we'll continue in tomorrow's session. Remaining points developing a plot plans and points to be considered to developing explosive tank farm, which required a CCOE approvals, that is Chief of Controller of Explosive approvals. And then we'll finish the plot plans, and then later we'll see different sketches of development of plot plans. So is it okay?
Yes, sir.
Okay, fine. Then we'll close.